Alice, and I work here at Cambridge University Press Bookshop. Most of the books we sell are aimed at grown-ups, but for the Cambridge Festival, I wanted to give kids a chance to quiz some of the brilliant experts who write them. I asked kids to send in their questions, and thank you if you were one of the ones who did. I got some brilliant responses. Then I put on my special interview jumper, jumped on Zoom, and asked them on your behalf. I had loads of fun doing these Q&As, probably because of all the cool questions I got to ask. There's a few little blips because we're all at the mercy of our internets. But I hope you enjoy them, learn something new, and feel inspired to carry on asking questions all your lives.
I'm Wallace Arthur. I'm an emeritus professor in the School of Natural Sciences at the National University of Ireland in Galway. My main field is evolutionary biology, but in recent years I've got very interested in astrobiology, and in particular in the likelihood of evolution having taken place on other planets than Earth.
My first question then is, when did the idea of alien life first become popular, and when did scientists start thinking about it seriously, thinking it could really be found?
Oh, that requires me to be a historian as well as a scientist. I think it goes back quite a ways. I mean, it certainly goes back to the time of H.G. Wells and War of the Worlds and all that. I think scientists have been interested in the possibility of alien life going back certainly before the 20th century to the 19th, but then going back beyond that, there was the interesting case of Giordano Bruno, the Italian, who was burnt at the stake in the year 1600. And one of his many crimes, according to his inquisitors, was suggesting that possibly all the stars we could see out there were distant suns, and all of those suns were orbited by planets, much like the planets orbiting our own local sun here, and that there might be life forms on all of those planets, or at least a good number of them, all over the place. So that takes us back to 1600. And in fact, if you go back to the ancient Greeks, Aristarchus of Samos predated Copernicus in suggesting a sun-centered solar system in approximately 200 or 300 BCE. So these things go back a lot further than most people realize. But I suppose things got a lot more serious in terms of our concrete ability to look for extraterrestrial life and to potentially send signals to such life in two stages. First, with the advent of the SETI movement, the search for extraterrestrial intelligence in the 1960s, when radio started to be employed for that sort of purpose. And then secondly, when exoplanets began to be discovered, and that really started in the 1990s. And the first Earth-like exoplanet was discovered in 2014, so really very recently. I mean, just in case not everyone's familiar with this term exoplanet, it's just a name given to planets that orbit stars that aren't our own local star, the sun. And so the first exoplanets that were discovered were a weird bunch of things, mostly called hot Jupiters because they were huge, like Jupiter, but they orbited really close in, closer than Mercury, a type of planet that doesn't exist in our own solar system. So those planets were fascinating, but not very interesting from a point of view of possible life, because you wouldn't really want to live on a huge planet that's being scorched right up close to its local star. So the really interesting stuff began in 2014 when we discovered an exoplanet with a lovely name of Kepler 186f, which was the first solid, rocky, Earth-like planet in the so-called habitable zone, or sometimes called the Goldilocks zone. In other words, just the right distance out from its host star to have liquid water on its surface. So we've kind of been in the business of really serious interest in extraterrestrial life on specified exoplanets only for the last 7 years, but with a history going back a couple of thousand years.
Thank you. So the next question then is, did life on Earth come from space?
Did life on Earth come from space? The short answer to that is absolutely not. Okay, I have a very clear view on this. Of course, it is just my view, and everyone can have their own view, but life coming ready-made from space, that's the theory of panspermia. So life originates somewhere else, and resistant spores manage to drift through space for centuries and eventually arrive on Earth and somehow magically revive themselves, and life on Earth is born, but it didn't start here, it started somewhere else. Could be somewhere else in our solar system like Mars, alternatively could be somewhere else much further away, one of these exoplanets that I've already mentioned. There's absolutely no evidence that this is possible. The probability of it happening is as close to zero as probabilities get. And we don't need it because we have perfectly good theories about how life could have originated on Earth. And in my opinion, it's a bonkers theory because it basically pushes the origin of life to somewhere where we can't even study it, rather than imagining that it was here, but we can study it. And it really doesn't solve any problems because it makes the origin of life more obscure than it would be otherwise, but it also adds to that the additional layer of having to survive all this crazy interstellar journey and get here intact and magically come to life again. So the idea that life came here ready-made from some other planet floating through space, the theory of panspermia, I think is absolutely not correct. However, having said that, we are made of stardust. We did, all our materials came from space. Our materials, the carbon in our bodies, for example, and all the other elements, were effectively made in dying stars and then scattered out into the universe at large. So the materials have come from space and the chemical elements have come from space, but our cells, our actual basic units as life forms have not. They started out here on Earth for sure.
Thank you. How far into space are humans able to search for life, and where are the most likely places to find it?
Okay, the answer to that depends entirely on whether we're looking for what I would call ordinary life or whether we're looking for intelligent life, because we look for these two types of life in very different ways. So our attempts to find alien life basically revolve around the use of radio transmission, either us sending radio transmissions out into space and hoping to hear from someone, or us listening for equivalent radio signals being sent to us from alien life somewhere out there. Radio transmissions can go an awfully long way. They do degrade with time and distance eventually, but we can look very long distances. And it's probably reasonable to say that we can look for radio broadcasts coming from other civilizations pretty much anywhere within the Milky Way galaxy. But now that means within up to a distance of about 100,000 light years, which is colossal, but with the proviso that it takes a long time for these signals to travel. So if we send a signal out to a star that's 100 light years away and has planets orbiting it that might have intelligent civilizations, it will take 100 years for the message to get there. And if they reply, if there's anyone there, then it will take 100 years for their reply to come back. And as far as we know, there's no exception to that, in the sense that this is Einstein's universal speed limit. Nothing can go faster than the speed of light, unless we later find that Einstein was wrong, and so far his theories have been borne out remarkably well, then we're stuck with these very long reply times. However, it's entirely possible that there was alien life on certain planets within the Milky Way thousands of years ago, and they might have sent out messages thousands of years ago, and so it's entirely possible that we could get those tomorrow. But it's just that if we then reply, it's going to take thousands of years for our reply to get back to them. So I think with regard to alien intelligent life, we can really look a long way, but we're plagued by the problem of long reply times. However, if you think then of looking for life that isn't intelligent, that's what I call ordinary life, okay? So it could be plants, animals, microbes, but things that don't have a human degree of intelligence. The thing that's probably easiest to look for there is the biosignature gas oxygen. So this would be produced by photosynthesis elsewhere, just as it is on Earth. So on Earth, we have an atmosphere with about 21% oxygen. And we have that because plants and microbes, certain groups of microbes anyhow, produce all this oxygen from photosynthesis. So in my opinion, the best way for us to look for evidence of life on another planet of the non-intelligent variety is to search planetary atmospheres for high levels of oxygen. And because oxygen isn't present at high level on bodies in the solar system other than the Earth, we're looking for high levels of oxygen on exoplanets orbiting other stars. Now, to come back to your question, the question really was, how far away can we look? And in terms of the techniques that we're using, this is basically forms of spectroscopy, where we're looking for signatures of oxygen, signatures in incoming light to us, light that's arriving here on Earth from afar. We can probably look for these signatures up to a distance of about 100 light years away. And so that's actually, although it's a crazy distance from the perspective of normal human life, it's actually quite a small fraction of the galaxy. So if the Milky Way is 100,000 light years across, that's pretty big. And we can only look for about 100 light years for these biosignatures. Then we're kind of restricting ourselves to something like 1,000th of the galaxy. We have also sent a lander onto Saturn's moon Titan, and it's the furthest away we've landed anything ever. So it's really quite phenomenal that we achieved that feat. And so that's the little craft called Huygens, which is part of the Cassini mission. And it landed on Titan, I think, in the year 2004 or thereabouts. And where it landed and took photographs, it's absolutely dry as dust. It looks very like Mars. However, we do know that in other parts of the surface of Titan, there are these hydrocarbon lakes and seas. And so it's always the case that there might be parts of the surface of a particular body in space that you haven't looked at that are very different from the ones you have.
Question from me. What does oxygen look like in light? How do you detect the presence of that in light?
Okay, so if you think of, well, the first thing to say here is that you have to be careful what you mean by light, okay? Because there's visible light, and then there's all the other parts of the electromagnetic spectrum, which can be referred to as light in a broad sense. So the electromagnetic spectrum starts with really short wavelength stuff like gamma rays and X-rays, and it goes all the way up to incredibly long radio waves. So somewhere in the middle of this great spectrum, we've got visible light, the light that humans can see. I mean, visible light itself is different for different organisms here on Earth, so we have to be careful of that too. But there's a little spectrum, a tiny part of the overall spectrum where humans can see light, and so we call this visible light. And then flanking that, we've got ultraviolet at one side and infrared on the other side. Now, oxygen has a particular pattern of absorption bands where it absorbs light, and these bands occur in the visible and what's called the near infrared bands. So the near infrared is the bit of the infrared that's very, very close to the visible spectrum, so we can almost see it, but not quite with our eyes. Again, interestingly, some animals, snakes, for example, some snakes can detect infrared or certain parts of the infrared spectrum anyhow. So basically what you're looking for, if you want to see oxygen, is you're looking for absorption bands in very specific places near the join between the visible and infrared parts of the spectrum. There's an oxygen A band and an oxygen B band, and if you find these bands, you get really excited.
Thank you. So interesting. Sorry. Oh, this possibility of alien life. It's brilliant. It's so interesting. Sorry, that was me. Right. So next question then. Did life first form in salt or fresh water, and do we know what sort of water is in space?
Well, the second question's easy. There's no water in space because space is too cold for water. However, there's water in lots of planetary bodies, which is perhaps more what the question was referring to. But let me start on Earth. The short answer to this one is that we really don't know where life started on Earth. We're almost certain that it was somewhere aquatic, somewhere watery. But there have been various different proposals as to what kind of watery environment the origin of life on Earth took place in. And I suppose the three main proposals, the first one is Darwin. Darwin said that life might have started in some small warm pond. And that's absolutely a possibility. So that would be a freshwater habitat. The British geneticist J.B.S. Haldane was, I think, the first to introduce the term the primordial soup. And he was thinking in terms of an expansive ocean of a soup-like consistency with lots of stuff in it that could be the building blocks for life. So that would then be a salty rather than a freshwater habitat. There is, of course, a continuum of brackish water between freshwater and proper salty water. So, I mean, there's a spread all the way there. And then the more recent theory is that perhaps life started on Earth in these incredibly hot deep sea vents that we now know exist, for example, along the mid-ocean, the mid-Atlantic ridge and other mid-ocean ridges. We don't know, to be honest, whether Darwin was right or Haldane was right or the more recent hydrothermal vent theory was right. So we really can't tell whether life started in freshwater, normal seawater, or ultra hot deep seawater. It's almost certainly one of those. So we can be sort of almost equally certain that it was an aquatic start as we can be uncertain which kind of aquatic start. And that helps because it means that when we're looking for parallel origin of life elsewhere in the universe, what we probably want to look for is water. So it's follow the water. We may not know which kind of water is most interesting to look at, but for sure we want to follow the water. And what that means then is that we want to follow the habitable zone, because we actually define the habitable zone around a star as the zone in which a planet can have liquid water on its surface. So if you think about our own solar system, the one which we know the most about, the planets Mercury and Venus are widely considered to be too hot for life, too hot for liquid water to exist on the surface. And then Mars and beyond is too cold for liquid water to exist on the surface. And it's interesting, Mars is kind of close to the join between the habitable zone and the outside the habitable zone area. And it does look as if it had running water in the distant past, and that connects with the recent Perseverance mission, of course. But right now, Earth is the only planet in the solar system that's well and truly in the habitable zone and that has liquid water on the surface. But when you go out then to other stars and their own planetary systems, it's quite likely that in most systems there's at least one planet with liquid water, one planet like Earth that's in the habitable zone, and these are the planets to look for life originating. The TRAPPIST-1 system has got 3 planets in the habitable zone, not just one, as in our own case here in our solar system, with Earth being the only one. So there may be some systems, some planetary systems that actually have a higher probability of life than here because they have more than one planet in the habitable zone and therefore more than one planet potentially with bodies of liquid water like oceans on the surface. And those are the places to look.
Does that mean then that Mars, sorry, this is me again, that Mars has been getting colder? Because I thought that the sun was getting hotter.
Yes, that's a great question. And a lot of people who like the idea of life on Mars in the past dodge that question. But let's not dodge it since you've raised it. It's absolutely true what you say about the sun. The sun is getting progressively hotter as it ages. And that's an absolutely inevitable feature. It's a feature of all stars. They do that. And so, other things being equal, you would expect the habitable zone over time to move outwards, not inwards. So, in the past, the habitable zone should have been further in, not further out, and Mars should have been even less habitable than it is now. So, we need some very good evidence to suggest otherwise, because we're suggesting something that goes contrary to that general trend of stars, not just our own sun, but all stars, for them to get hotter as they age. And the answer to this puzzle lies in the atmosphere. Mars now has a very, very thin atmosphere. But in the past, it was probably thicker. And thicker atmospheres can really upset things. I mean, what you normally expect is that the further out from the local sun a planet is, the cooler it's going to be. And generally speaking, that's true. But if you look at our own system, Venus, the surface of Venus is actually hotter than the surface of Mercury. It's further out from the sun. So why on earth is it hotter? It's hotter because it's got an ultra dense atmosphere and it has what's called a runaway greenhouse effect. And so the surface of Venus is horribly hot. It's sometimes described as a hellish environment. It's an even worse place for life than the surface of Mercury. So what we think is that in the past, Mars had a thicker atmosphere, and this produced a greenhouse effect, maybe even a runaway greenhouse effect on Mars. And therefore Mars, even though it was at a position in the solar system, which at the time should have been rather cold, actually this atmosphere meant that the surface of the planet was much warmer than it otherwise would have been. And so we see actual evidence for that in the sense that we can see, how would one put it? It's sometimes been described as like the rim on a bath when the water's gone out. You can actually see these rims. You can almost see a series of them, like as the water fell, you can see different levels at which the water was at different times. And it's also important to be clear, not just that this was liquid, which it obviously was, but that it was water rather than some other liquid, because we know, for example, that on Saturn's moon Titan, there are seas, oceans, but there are not oceans of water, there are oceans of liquid hydrocarbon. And that's not as conducive to life, as far as we know, as liquid water. But if you look at the chemistry associated with these places where there was liquid running in the past, you find the formation of crystals, various things that only form in liquid water rather than in liquid hydrocarbon. So all the evidence that we have makes it almost certain that there were large bodies of liquid water on Mars in the distant past because of it having a thick atmosphere, causing a greenhouse effect, and therefore causing it to have liquid water on the surface, whereas it otherwise wouldn't have. And one of those places with liquid water in the past was Jezero Crater, which is where Perseverance has just landed, and that's very exciting.
Then the next question I have here is, by life outside Earth, do scientists mean animals, plants, or something else?
The answer is all of the above. Yes, I mean, animals, plants, and microorganisms are all fair game for possible forms of life elsewhere, as indeed are forms of life that are not found here. So, for example, There was the famous science fiction writer John Wyndham, who had those predatory plants called triffids, which had a combination of plant-like and animal-like capabilities. So they photosynthesized, but they also ate things. Now, although science fiction is a very different undertaking than science, it's something that's worth paying attention to, because sometimes what science fiction proposes, real science later discovers. For example, in the early days of Star Trek, a lot of the action was based on what we would now call exoplanets. They just assumed that exoplanets existed without any evidence for them. And then about 30 years after the first Star Trek, we started getting evidence. So I think the message, don't knock science fiction, is probably a good one. I think, though, there's an interesting comment to be made about the relative commonness of the different types of life. So I think we would expect microbial life on bodies outside the Earth to be much commoner than animal and plant and human life. Simply because if you look at Earth, there's been microbial life around here for 4 billion years. There's only been animal life for a bit over 500 million years. So the microbes have been around, let's say, nearly 10 times as long as animals. And so what that means is, if you take a bunch of planets beyond the Earth, beyond the solar system, and you look at them, you don't know what age they are. Some of them will be old, some will be young, some of them will be middle-aged. The young ones are probably only going to have microbes, at least if they've got an evolutionary process similar to the Earth, because they simply won't be long enough in the tooth to have animals and large plants. So what we should expect to find depends on how old the planet is, and quite often we don't know how old it is, and probably we should make the assumption that we're looking at a cross-section of planetary ages, and the young ones, microbes are probably the best we can expect. The old ones, intelligent life is entirely possible.
Question then came in, kind of blew my mind, but I'll ask it anyway. Could alien life be made of antimatter so we couldn't detect it?
I thought about this. I don't claim to have come up with the answer. I actually think there's a greater probability that we should take seriously the possibility of life based on this mysterious dark matter. So not only do we have what we think of as matter, the kind of normal matter, which is neither dark nor anti, okay, but you then have antimatter, but you also have this stuff called dark matter that we don't even know what it's made of yet. Now, when the universe was born, the matter and antimatter more or less annihilated themselves. They kind of negated each other, if you like. And what we've been left with is essentially matter rather than antimatter. So probably from the perspective of the current day, the present day, we can forget about antimatter. However, we can't forget about dark matter, because the present thinking is that approximately 80% of the mass in the universe is dark matter, and only 20% of the matter is normal matter that you and I and everybody else and everything else that we know about is made of. This puts us in a very bizarre position, because if it's true that 80% of everything, all matter, that is made of something that we don't know anything about, then we are absolutely flailing around in the dark. Now, we don't even know whether this dark matter is made of things called WIMPs. WIMPs stands for weakly interacting massive particles. So these are things that are bigger than protons and neutrons, or perhaps things that are smaller than protons and neutrons, things like the particles that have been called axions. Now, nobody has the faintest idea whether either WIMPs or axions exist. Therefore, we have no idea what dark matter is made of. And yet it almost certainly exists, and it almost certainly makes up the bulk of the matter of the universe. Could life be made of dark matter? Well, we really can't rule that out, because we don't know what it is. So there may be a whole other category of life that, rather than being based on our minority form of matter is instead based on the majority form of matter, which is dark matter. It's absolutely mind-boggling that dark matter was discovered in the 1930s, and here we are nearly a century later, and we're no more the wiser as to what it is. So there's a huge gap in our understanding of the universe, and correspondingly we should be, again, somewhat circumspect and say, could life be based on dark matter? Well, why not?
A bit more evolutionary sorts of questions now, I think. First one then is, if there's another planet like Earth, would evolution happen in the same way, and would there be humans on it?
You started with, if there's another planet like Earth. In the observable universe, there are almost certainly trillions of planets like Earth. So, you know, it's a tiny fraction of all planets, but it's still trillions as an absolute number. And so there's oodles of Earths, okay? Will evolution have taken similar courses, similar routes to the routes it's taken on Earth? I'm of the opinion that it almost certainly will have done, with one proviso. I think that evolution will operate in parallel if the environments are in parallel. Because after all, what Darwinian selection does is to adapt creatures to their environments. And there's no reason to believe it will behave any differently if you're on the surface of an exoplanet rather than on the surface of the Earth. So if the environments are in parallel, then probably the creatures that it will end up producing will also be in parallel. Now, what this means is, if you think about it, in the habitable zone, there's water. And on any planet, there's going to be topography in the sense of hills, mountains, valleys. We don't know of any planets that are like a spherical version of a bowling green. We don't think they exist. So you can take it that topography is everywhere. The force of gravity is everywhere. And if you're in the habitable zone, then water on the surface is everywhere. Now, if you just take those three givens, then there's got to be streams, rivers, lakes, oceans. There's got to be habitats at high altitude, low altitude, high latitude, low latitude. There's probably going to be places where plants can't grow any taller than a meadow. And there's other places where plants will be able to grow as high as very tall trees or even higher. So there's going to be a whole diversity of habitat types which will broadly parallel the Earth. From the point of view of the evolution of animals, then, it seems reasonable to believe that natural selection will do the same sort of thing as it's done with animals on Earth. It's adapted some of them to aquatic habitats, some of them to surface habitats, some of them to even aerial habitats like birds and bats and insects. So I would personally expect, at a broad brush level, that the normal thing we will find, the rule rather than the exception, again, if you like to put it that way, is biospheres consisting of vaguely Earth-like animals, things that will look more familiar than unfamiliar to us. However, having said that, it's hard to take these parallels down to the level of fine brushstrokes. And therefore, whether there will be particular species that are similar to the species on Earth, I think is much more of a moot point. I think it's harder to try to generalize about that and be confident about it. Therefore, I'm not personally certain that if there are intelligent life forms elsewhere, they will be humanoid. They might be, and I think we shouldn't rule out the possibility that they would be, but I think we should consider other possibilities too. And it's interesting to think about how intelligence has evolved on planet Earth, because we're the most intelligent vertebrate animal for sure on planet Earth. If you cast your eye across the much bigger part of the animal kingdom, that is the invertebrate world, and ask, well, what's the most intelligent invertebrate on planet Earth? Well, it's quite clearly an octopus. Now, the evolution of octopus intelligence and the evolution of ape and human intelligence, those have been two completely independent evolutionary trajectories. starting at different points, and taking different periods of time and culminating at different sorts of brains, but in both cases incredibly large and intelligent brains. And so imagine on some other planet that for some reason humans would ever evolve. Perhaps there aren't any trees, I don't know. So perhaps the primates never happen. And perhaps instead of thinking of things like dolphins being mammals that go back into the water, extraterrestrial octopuses come out of the water and invade the land. Now, an octopus has got a big brain, and it's got very impressive manipulative appendages, and it hasn't just got 2 of them like our arms, it's got 8 arms. So that's great for manipulating objects and therefore for developing a technology. And if they manage to evolve onto the land where you don't have the problem that metals rust, and so you can potentially develop a metal-based technology, then you could be flying, as they say, not literally, but flying in the technological sense. So my personal guess is that intelligent life forms on other planets will be animal-like, will be bilaterally symmetrical with a left and a right side and a head and a tail end, and with highly maneuverable manipulative appendages. But whether it's just 2 manipulative appendages or more, I don't know. And whether these creatures will be humanoid and therefore vaguely in the group or a group similar to our vertebrates, or whether they'll be more molluscan like an octopus, well, that's another matter. Don't know. Probably, since there'll be so many planets out there with intelligent life, there'll be some that are humanoid and some that are not.
If life was growing on other planets, do you think humans would try to destroy it or look after it?
I'm actually quite optimistic on this count, and I'll tell you why. I think as humans have progressed over the years, although it couldn't be said that we've got better in all respects, I think there has nevertheless been an underlying trend in parts of human society to be a bit kinder to other life forms than we used to be. I'm thinking partly of the conservation movement, which is a relatively recent invention, if you can call it that. And I'm also thinking, in addition to conservation, I'm also thinking of the field that's these days labeled planetary protection, which is something that's particularly championed by NASA and ESA and the other space agencies. So, for example, when the Cassini mission was finished, this mission to the system of Saturn, it was deliberately crashed into Saturn, which of course itself is a gas giant planet, and so we don't expect there to be any life there. It was basically ensured that it didn't end up crashing onto one of the moons of Saturn, which are potentially venues for extraterrestrial life. Now, I'm a little bit skeptical about life on Saturn's moons, but nevertheless, we do know that at least one of them, the moon called Enceladus, has subterranean oceans. And so there are moons in that system which are at least potential homes for life, whereas Saturn, the planet itself, is almost certainly not. And increasingly, the space agencies, both NASA and the others, are thinking in terms of planetary protection, are thinking in terms of not contaminating places that just might have some form of life of their own with earthly life or with Earth-originating debris. So I do think that conservation and planetary protection are movements that are growing, that are relatively recent, that are expanding, and I think they give us some hope for humans behaving in a wise way when we finally do ourselves as explorers arrive at planets where there may be life. And that's a long way in the future. It has to be said that our own track record with planet Earth still leaves a lot to be desired, but I do think we're getting better. Whether we're getting better fast enough is another matter, but I think we're at least going in the right direction.
Is it possible to be more evolved than humans? Could there be super intelligent races out there?
The answers are yes and yes. I would expect that there are some ultra super intelligent races out there. And you only have to think of the time dimension of the universe to see how that's not only possible, but really extremely likely. So we know that the universe is approximately 13.8 billion years old. It's nice that we now know this. We really have a good idea of how old the whole thing is. We also know how old the Earth is. It's 4.6 billion years old. And to me, those figures have an absolutely fascinating coincidence built into them, because the age of the universe at 13.8 billion years is exactly 3 times the age of the Earth at 4.6. Spooky. Now, the thing is that life on Earth started about 4 billion years ago. So it started shortly after the Earth began. But the thing is that there were some Earth-like planets around way, way, way before the Earth began. In fact, there was time for whole solar systems to arise, go through the whole of their evolution and die before the Earth even came into existence. Now, some of those, of course, will in the end have been wiped out by events like asteroid impact. Those that managed to go the whole hog, if you like to put it that way, until their sun dies, and they might, in the fullness of time, therefore evolve the capacity to leave their home planet and keep going to other solar systems where the sun hasn't died. Those intelligences could be insanely beyond where we are now. And so we should anticipate the likelihood, I think I would put it as strongly as that there are civilizations out there that are not like a few hundred years or a few millennia beyond us, but that are rather millions of years beyond us. And that's kind of a sobering thought.
Especially sobering if they're trying to communicate with us, but we're too stupid and backward to understand.
That's entirely possible.
People send like the golden disc and stuff? Why are there things like that being sent into space?
Well, that's a very good question, because there are 2 views on this, and one of them is that it's highly stupid to send information about us into space, given that we don't know what aliens exist, how many of them, and which of them are friendly and which of them are hostile. And arguably, all the information that we send could be used against us. So do you really want to do that? Now, there's always been, 2 opposing points of view on this. Oh, let's just, the gung-ho approach, let's just go ahead and send it. I'm sure they're friendly. And the cautious approach, which says, well, let's not, because we don't know. And there's an interesting anecdote that when the famous Arecibo message was sent out, which had all the kind of golden disc information that you're talking about, but in the form of a stream of binary digits. This was sent out from the radio telescope of the same name, Arecibo, which unfortunately is just recently defunct due to cables crashing onto the top of the thing and now beyond repair as from, I think, a few months ago. But this was sent out in the 1970s, and it was Frank Drake and the other American pioneers of the SETI movement who decided to send this message out. And apparently the British Astronomer Royal of the time wrote to Frank Drake and said, are you sure you want to do this, sending all this information out about humanity to beings who may, for all we know, be hostile? And the response he got back was, look, it's really too late, because we've been leaking radio waves into space ever since the first broadcasts in the early 1900s. So the chances are they know about us anyway. However, I think beams sent deliberately out into space with content deliberately aimed at being interpretable by aliens are very different from slight leakage of Radio 1 programs or whatever were their predecessors into space. which might conceivably be picked up by aliens. So I think that response was a little odd. So there have always been two points of view on that issue, and there remain two points of view, but I'm actually quite pleased that there have been these so-called breakthrough initiatives, which started in 2015, spearheaded by Yuri Milner and involving a lot of famous folk, including Stephen Hawking at the time. As part of that, there's a new stimulus towards more SETI-type work, so more radio signals to be potentially sent out. But rather than starting from the point of saying, right, what will we send out next, they're actually starting from the point of, well, what are the ethics of this issue? And shouldn't it really be a worldwide endeavor rather than something just sent out kind of off the cuff by a particular bunch of scientists at a particular observatory? So I think we're going in the right direction. It is always possible that it's too late because we've sent out that stuff already.
That's the end of my questions.
Okay, well, those are great questions.
So fascinating talking to you about this, and that hence the fact that we've overrun and I threw in a few questions of my own, but thank you so much for tackling.
Yeah, I have much enjoyed the conversation, so thank you too.
Thank you very much, Wallace.
All right, cheers, Alice.
Thank
Hope to see you again sometime.
Hopefully.
Bye.
Bye-bye.
Bye.